You have probably already seen a lot of Snapmaker U1 unboxing videos. Tool changing, Core XY, 270x270 build volume, AI camera, LED lights. Yeah, all that looks cool. But today I'm not just unboxing this printer. I want to test the technical details that many creators skip. Testing all features in real time, advanced option of clipper firmware, and something interesting I noticed about power consumption of a Snapmaker U1. This video is not sponsored. I bought the Snapmaker U1 with my own money, so everything you will see here is my honest experience. Toolchanger 3D printers have existed for a few years, but most of them either require a deep technical knowledge or expensive, like the Prusa XL. Snapmaker U1 is interesting because it tries to make tool changing affordable and user-friendly. First thing, the box is heavy. Please keep someone with you while removing the printer. Inside we get the manual on top. The packaging is very tight and well done, which explains why the printer arrives without damage. A lot of protective tape everywhere, and surprisingly, 2 boxes inside the printer. Probably one reason for the weight. Front glass panel feels thick and premium. Inside the accessories box, we get a good quality scraper, grease, brass cleaning brush, pliers, PTFE tubes, nozzles, and other things. We also get 4 spool holders, USB-C cables, filament feeders, wedge filament collector, and the hero of this printer, 4 tool heads. Let's take a closer look at the tool heads. The back panel is magnetically attached, easy to remove. Default nozzle is 0.4 mm stainless steel, and Snapmaker also offers a hardened steel nozzles if you want to unlock more materials and higher volumetric flow. You can see the extruded motor, cooling fan, magnets, pogo pin connector for power. Everything is packed very compactly. The engineering here is quite impressive. Assembly is straightforward, but important. First, remove all shipping screws and protective parts. Attach the wedge filament bucket. Now the important part, attaching tool heads at the correct angle with the correct setting. Connecting them via USB-C. Routing PTFE tubes neatly using clips. And connecting filament faders and spool holders. Once everything is connected, power cable in, and we are ready to turn it on. But before, if this is your first 3D printer, I highly recommend please read the instruction manual properly before unboxing and turning on the printer. Initial setup is familiar: language, region, Wi-Fi or LAN. Calibration takes time. In that, multi-toolhead calibration, thread leveling, vibration compensation. The printer handles most of it automatically, but it does ask you to interact sometimes, like cleaning nozzle with provided brush and removing the build plate during calibration. Total calibration time is around 30 minutes. I loaded a Snapmaker filament with RFID, which comes with the printer. One thing I noticed, filament loading is super smooth. Just insert the tip of the filament and the filament feeder cools it automatically. Even if you insert 2 filaments on each holes at the same time, it handles them one by one without tangling. Good job, Snapmaker. Touchscreen is smooth and responsive. You can load and unload filament, control temperature, adjust fan speed, attach and detach tool heads, move access manually. Other important features: LAN mode, time-lapse export to USB option, advanced mode thanks to clipper firmware. Advanced mode gives you a deeper control, but it's better suited for experienced users. 4 color dragon. This is a preloaded file. I started the print using the mobile app. Each time we start the print, it tests every toolhead and loads the filament individually. If print contains 4 colors, then it takes long time to start the print. Tool changing is smooth. no issues. Also, here is the important technical detail I have noticed regarding power consumption. I will explain it to you in few minutes. Stay tuned. Print took around 3 hours. For comparison, this is the same print in 4 colors would take 12 to 15 hours on Bamboo Lab A1 series. That's the difference between color changer and tool changer. Next one, rose print. Edges and top overhangs of this rose print looks great. Pass through cone. The edges are coming out good. Smooth movement, clean tolerance. Sunflower flexible coaster. Dual color flexible interlocking coaster print came out perfect. Toothpick dispenser with PETG springs. Printed PETG spring using a bamboo PETG. Snapmaker Orca doesn't have a Bamboo Lab filament profiles, so I created one manually. The PETG spring is strong, and after final assembly, the functional part works good. Multi-material printing, flexible airless ball. Printing PEBA flexible filament with a PLA support. PEBA flexible filament loading is smooth like other filament. No tangling issues. After printing, the PLA support part removal was smooth, and this is where multi-material printing shines. Printing full test print, which include bridges, overhangs, tiny benchy, stringing and other tests. As you can see, this also came out almost perfect. Only pin test has a problem. Here's the technical detail I noticed that many creators haven't talked about. During multi-tool printing, the active tool head is fully heated. Expected. But when the printer prepares for the next tool change, the upcoming tool head also start heating in advance. So at one point, 2 tool heads are fully heated, while the remaining ones stay at around 70 degrees standby. Once the current tool head parks, it cools down. The printer then switches to the already heated tool head and start heating the next required one. And this cycle keeps repeating throughout the print. Why does this matter? Well, heating element consumes the most electricity in 3D printing. So this repeated heating and cooling may increase power consumption. I'm not saying it's bad. I'm saying it's something worth measuring properly. If you want, I can do proper power consumption test with real measurements. Let me know in the comments. Next one, Snapmaker U1 can detect build plate obstructions. To test this, I place an object directly on build plate and tried starting a print. And yes, the feature worked perfectly. The printer detects the anomaly, stopped the print and warned me before anything bad happened. This is one of the features you don't appreciate until it saves your printer one day. The Snapmaker U1 AI camera supports spaghetti detection, air printing detection. So of course I had to mess with it. I removed the print while it was printing to see if the system reacts. At first, spaghetti detection didn't trigger. I checked the settings. Spaghetti detection and other settings are on, but the air printing detection off. Turned air printing detection on. After a few minutes, the printer stopped the print automatically. Yes, it actually detected the failure. Spaghetti detection is activated. But air printing detection feature is activates when filament tangles or nozzle clog happens. And trust me, these things always happen when you are not in the room. Clipper firmware, enthusiast mode. Another big win for Snapmaker U1, it runs on Clipper firmware. For 3D printing enthusiasts, this is huge. All you have to do, enter the printer's IP address in a browser and boom, you get access to console commands, full control panel, detailed G-code preview, advanced customization and many more options. But quick warning, if you are a complete beginner and this is your first 3D printer, stick with the front-end touchscreen for now, because sending the wrong commands in the backend can damage your printer. Learn it slowly, it's powerful. Improvements and things to know. No printer is perfect, so let's talk honestly. I experienced the front panel makes it harder to see the first few layers on very small prints. Also, camera has latency issues. The rare USB port placement is inconvenient, at least in my table setup. I feel it's slightly louder than bamboo machines. Sometimes it reminds me of my Crealytic haven. If the extruder gets clogged, toolhead disassembly may feel complex for beginners, mainly because of a tiny wires. Although Snapmaker has a detailed official videos, which helps a lot. Snapmaker Orca Slicer feels a bit laggy right now. This can likely be fixed with the future updates. For now, I personally prefer using a standard Oka slicer with extra settings. The top enclosure is sold separately, which limits printing materials like ABS and ASA out of the box. And also filament spools are exposed to moisture and dust. But most of these issues are manageable and many 3D printed modes are already exist. And yes, I'm planning a videos on those mods very soon. Subscribe and stay tuned for that. Despite some small drawbacks, I genuinely love this machine. Multi-toolhead printing unlocks a real multi-material capabilities. Large build volume, smart feeder system, AI camera with cool features, open source Clipper firmware with user-friendly interface, and beautiful design. I feel this Snapmaker U1 is not only tool changer but also game changer in 3D printing industry. But in my opinion, if you are new to 3D printing and want a single color, single material fast prints, there are other great options too. But if you want a multi-material printing and additional printer to tinker with, then Snapmaker U1 is absolutely worth considering. More mods, upgrades and experiments videos on the Snapmaker U1 are coming soon. Stay tuned. Till then, happy printing.